Hi, this is Jason McIntosh with McIntosh Applied Engineering. I'm going to show you the MAE206 microphone amplifier in this video. The 206 amplifier is mostly meant to work with two-channel sound cards, and so the inputs and outputs are labeled left and right to correspond to the sound card left and right channels that are typically found. The 206 has two types of inputs. The first input is a 3.5 millimeter stereo connector, where the three pins on that stereo connector are used for a microphone, where one of the connections is for signal, the other is for the power, and then the third is for ground. So that's something that's typically found in an analog MEMS microphone. These BNC inputs are used for pretty much any other single-ended signal. A phantom supply can also be selected for these inputs so that you can run an electric microphone directly off of the inputs to this microphone. To give an example of its operation, I'm going to connect a MEMS microphone to the left channel input. This is just a standard analog MEMS microphone, and to display it I've got an oscilloscope connected here, and I've currently got the microphone set up to have a 20 dB gain, so as I bring the microphone up to my voice I can talk and the oscilloscope is picking up my voice. That's a simple analog amplification of a microphone. So now I'm going to connect an electric microphone up to the right channel of the amplifier. This is a standard 4.5 millimeter diameter electric microphone that requires a phantom supply. So I'm going to go ahead and hook it up to the right channel. The right channel is configured to have a phantom supply turned on. I'm going to take the channel 2 from the oscilloscope, connect it to the right channel output, and as I bring it to my voice, or bring the microphone to my voice and I talk, you can see the signal is showing up there. So this is the typical behavior of the microphone amplifier. I'll go over to the computer and go through some more details over there. Here's a close-up of the front and back panels on the microphone. The gains that the microphone can support on both the left and right channel are from minus 20 dB to positive 40 dB. The minus 20 is useful if you have, for instance, if you have, let's say, an 8 ohm speaker that's rated at 20 watts and you're playing high crest factor signal into it, such as speech, you can get very high voltages in that situation. If your sound card is limited to just 5 or 10 volts and you're getting 40 volts across that speaker, you'd clip the inputs. So this minus 20 dB pad is very useful for those situations. I mentioned we got the 3.5 millimeter input. The tip is the signal. The ring on the connector is power, and then the barrel would be ground. The voltage for the power signal can be adjusted by opening the case from half a volt to 3.3 volts. Some hearing aid microphones are around 1 volt. Most consumer electronic microphones are around 2 volts. The amplifier also has the capability of providing a 100 millivolt peak to base 1 kilohertz calibration output. This is useful for calibrating the inputs for a sound card. The ARRI software uses this kind of a calibration signal for calibrating the inputs for the sound card. The amplifier doesn't have any controls on the panels. It's controlled through a USB connection, which is accessed through a Windows program shown here. I'll go ahead and bring up the actual program instead of that dialog box in the PowerPoint. When you run it, you select which device you want to control. In this case, it's only finding one connected to the system with the serial number 13. You can turn the LED on or off on the front panel. You can turn the calibration signal on or off. The left and right channels operate independently. You can turn phantom supply on for one but not the other. And then the gains for the different channels also operate independently. So it has a nice, simple interface with this program. which is provided with the amplifier. If you have an interest in this, MAE can supply these amplifiers to you. Please just contact us and let us know. Thank you for your time.